So, good evening, everyone. So, in the previous class, I have explained you the concept related to the traces. That means how you will solve the truss problems. So, I have discussed the only first method, that is the method of joint, and we have solved more than 2 to 3 problems. Then one more problem is there. So, in basically in case of truss, what you will do, you will find the force in the intermediate member. Okay. So this is the question. The force in the member BC of the truss is shown in the figure below. Okay, so this is basically the truss. So which is subjected to a load 1200 Newton, 400 Newton. Okay, so there are the four options you have to calculate. There are the four options given. We have to calculate the force in the member BC. So what is the force in this member BC? You have to calculate. Okay, so what you will do, first of all, you will calculate the reaction at the support, because this is the first step. The first step is you have to calculate the reaction. So how you will calculate the reaction? By using the equilibrium equation. Okay. So this is basically a hinge joint. That means there will be two reactions. One is the in the vertical direction, RAV, and another will be in the horizontal direction. Let us suppose RAH. Okay. Now there is a roller support. That means there will be a vertical reaction, that is RDV. Okay. So what is the equilibrium equation? The step first is you have to consider the equilibrium equation in the x direction, summation of force in x direction 0. What are the forces acting in the x direction? The force acting in the x direction is one is the reaction and another will be the 400 Newton. Okay, so that means the RAH, which is acting in negative direction. So this is, let us suppose, minus, then positive because it is in this direction. So I'm considering this is a x, this is y axis. So this is the positive direction of x axis, this is positive direction of y axis. Similarly, so this will be negative x axis, this is negative y axis. Okay. So this value will be 400 is equal to 0. So what is the value of reaction at A in the horizontal direction, which is nothing but 400 Newton. 400 Newton. So you got the reaction at A point, which is nothing but 400 Newton. Now, the next thing is you have to calculate the vertical reaction. So you will consider the equilibrium equation in the vertical direction. So summation of force in y direction 0 means RAV plus RDV is equal to 1200. Why 1200? Because these are the two forces acting in the vertical direction. Okay. And one will be the force which is acting in the vertically downward direction. Now, there are the two unknown, but only one equation is there. Then what you will do, you will use the third equation, which is nothing but the summation of moment about any point will be 0. Summation of moment about any point. So I'm considering a point A, which will be equal to 0. That means what are the forces which will create the moment? One is this force and another will be this force. And one more force is there, that is 1200. Okay. You are taking the moment about A point means these two forces are, or the reactions are passing through the same point. That means the moment of these forces will be 0. So only these three forces will create the moment. Okay. So what will be the moment about A? So RD V into what is this distance? This distance is 12 into 12 is equal to, then this one will be the 400 into 3, one moment, because you have to calculate the moment about A point. So 1200 into 8. So can I write 400 into 3 plus 1200 into 8 will be the moment. So what is this value? RDV into 12, which is nothing but 1200, 9600. Okay. So if you calculate, this value will be RDV is nothing but 900 Newton. So you got the reaction at the D point in the vertical direction is 900 Newton. So if you use the first equation, you will get the reaction at A in the vertical direction also. Okay. So what will be the value? We calculate RAV plus RDV is equal to, this value is 300. This 100 means RAV value will be 300 this value will be 1200. This value is given as 1200 from the first equation. So RAV is nothing but 1200 minus 900, which is equal to 300. Okay, so you got the value of reaction at A in the vertical direction is 300. Okay, so you know the reaction at A point, reaction at D point. Okay, now what you will do? You will use the method of join. So you have to calculate the force in this particular member, the force in this perpendicular, this point. Okay, so how you will calculate? So suppose if you will consider the method, if you consider the point joint A, what are the forces which is acting? This force and this force. Two are known force and two are unknown. So you have the two equation. You can easily calculate the force in member AG as well as in AB. Okay, but you have to calculate in BC. Now, again, if you consider this point, so this is the one force, this is the one reaction which is force in the member. There is no force which is acting at B point. That means whatever the force in the AB, that will be balanced by the BC. Okay, so that means you have to consider first of all the point A or the joint A. You will get the value of AG and AB. Then you can easily calculate the force in member BC. Okay, that is the meaning of method of joint. You have to move from one joint to the another joint to calculate the force in any member. Okay, now I am doing that one. So let us suppose the joint A, what are the forces acting? This is 400. This value I have calculated as 300. And what are the intermediate force? This is force in AG. Let us suppose this is force in AB. This is force in AG and this is force in AB. This is force in AB. Okay, so let us suppose this is the theta angle. This is the theta angle. What is that angle? I don't know. I will easily calculate because this dimension and this dimension is given. So for example, this is theta angle. So if I will consider tan theta is nothing but perpendicular by base. So 3 by 4, that means theta is equal to, you can easily calculate the theta value. You can easily calculate the theta value, tan inverse of 3 by 4. Tan inverse of 3 by 4. Okay. That means you know the theta value. So you know the property of this triangle also. For example, this is 3, this is 4, this is 5 only. What is the sine theta here? Because by using Pythagoras theorem, you can calculate this value. What is sine theta? Sine theta will be perpendicular by hypotenuse. Cos theta is base by hypotenuse. Why I have calculated sine theta cos theta? Because if I will resolve the forces, this in x and y direction, then cos and sine component will come. That's why I have calculated. Okay, now just to resolve this particular force in this direction and this direction. What is this value? FAG cos of theta, FAG sine of theta. FAG cos of theta, FAG sine of theta. So the force acting in the x direction is FAB plus FAG cos theta. And the next force will be equal to 400. Let us suppose this is the first equation. Then the second equation is FAG sine theta plus 300. FAG sine theta plus 300. Why plus 300? Because both are acting in the same direction is equal to 0. Is equal to 0. So can I calculate FAG value? Yes. Minus 300 divided by, what is sine theta value? Sine theta is 3 by 5. So this means this value is minus 500 Newton. What it means? 500 Newton means the 500 compressive. Okay. So please do not mistake while considering the sign also. Minus value is indicating the force in the AG member, it will be compressive because this negative sign is coming. Now, similarly, you can calculate the force in member AB. What is the force in member AB? Force in member AB is nothing but 400 minus FAG cos of theta. Yes or no? Because this is 400 from the first equation. FAG value is minus of 500. That means it will become 500. Cos theta value you are getting as a 4 by 5. So this value is 4 by 5. That means this will become 800 Newton. 800 Newton. Okay, so once you know the value of FAB 800, that means this force you have calculated, which is coming out to be positive. So which is coming out to be positive means it will be tensile. So same thing, if you consider this joint, so if it is acting like this, so here will be, the force will be in this direction. So at this point, if you draw a free body diagram of this joint, what is the force acting? This is the force AB. and this will be the force. This will be the force BC. Okay, I'm considering this particular joint. These are the three members which are meeting. So this is nothing but the force in BC, and this is force in BG. Force in BG. Okay, that means whatever the force which you got, this 800, that will be balanced by FBC, or otherwise you can consider summation of force in x direction 0. What are the forces acting? FAB is equal to FBC. Yes or no? Because this is acting in this direction and this is acting in this direction. That means I can write the FBC force is nothing but 800 Newton, and which will be the tensile. Why tensile? Because you know that you assumed this is a tensile nature and you are coming as a positive value. That means your assumed direction is correct. So this value is 800 and that will be balanced by this FBC. So FBC is also the 800 Newton tensile. So what will be the correct answer? So once you check, there are the four options. So this C is the correct answer. Okay.
Good evening, sir.
Now, yeah, good evening, Raj.
Sir, till
Why
now,
you
what is
joined
being
here?
dis-
Okay, so in the previous class, I have discussed till here. Okay, so method of joint only. So we have solved the 2 to 3 problems. So one my problem, I have discussed this one. Okay, you can see in the recorded one also, but if you want, I will explain. So this is basically a structure. So you have to calculate the force in member BC. How you will calculate the force in member BC? First of all, you will calculate the reaction. Okay, the same thing which I have discussed yesterday. First step is calculate the reaction at this point. How you will calculate the reaction? Take the summation of force in x direction, take the summation of force in y direction. Then you will get the reaction at A point as well as D point. So this is the A point, and the reaction at the D point you are getting as a 900 by using the three equilibrium equation. Then what you will do? You will consider the joint number A. You will consider the joint number A, and then you will apply the forces. You will apply the forces. This force is basically acting as a theta. So you resolve this force. Again, you have to use the summation of force in x direction, summation of force in y direction. So you have to calculate the force in member BC in this member. So once you know the force in member AB, this force will be balanced by this only, because if you consider this joint, this is the force which will be balanced by this, then you will get the FBC force is 800. So same type of problem which I have discussed previously. That means in every method of joint, you have to calculate the reaction first. Then after that, you have to move from joint to joint. For example, if you consider this joint, these two forces you can calculate. Then if you consider this joint, the other forces also you can calculate. Okay, so one more problem is there. Even if you have missed, just be with me in this question. This problem was asked in the GATE 2016. How you will solve the two-member truss PQR is there, which is supported a load W. The axial force in member PQ and PR you have to calculate. Okay, so the angle is also given. So how you will calculate the forces in member PQ and PR? Very simple. Just consider this joint. One force is known to you, which is W, and which is given in terms of, the options are given in terms of W only. That means you have to calculate the force in member PQ and the force in member QR. Okay, so the angles is also given. What you will do, you will consider the method of joint only. That means you will consider this joint, just take the forces and write down the equilibrium equation, summation of force in x direction, summation of force in y direction. Because one force is known to you, which is, if you see the options also, they are given in terms of W. For example, they can frame the question. They will give you, let us suppose this W is 100 Newton. So instead of W, it will become 200. Okay. So let us suppose this is the particular question. So what I will do, first of all, I will consider the joint Q. What are the forces acting? One force which is acting in downward, W. So now the next force, if I am considering, let us suppose the force PQ in this member, and the another force is there, which will be in that member QR. Let us suppose the force in member QR will be this. So here the angle is given as 60. Here the angle is given as. Then what you will do? You will consider the equilibrium equation, just to resolve this force in y direction as well as the x direction. And you know how to resolve the forces. Yesterday I have discussed more than 2 to 3 problems. What you will do, you just resolve the forces. Means if there is a 60-degree, that means theta is acting here. What will be the force in this direction? Okay, so I am just representing here what will be the force here, which is nothing but f of qr cos of 60. Because whenever the theta is there, I told you, whatever the force is acting, cos component will come here, sine component in the other direction. So what is this one? F of qr sine of 60. Sine of 60. Okay, this is the force. Whatever the direction of this arrowhead, the same force you can resolve, or you can write in this same format. Like, for example, this is the force. If you are resolving, so one will be the vertical force, another will be the horizontal force. Now what you will do? Summation of force in x direction 0 and summation of force in y direction 0. Okay, what is the force in x direction? F of pq plus f of pq plus, or I can write, if f of pq is minus in this direction, because I'm considering this is a positive x-axis, this is the y-axis. So in this direction, this will be negative, and this direction it will be positive. So minus of f of pq and f of qr sine of 60 is equal to 0. First equation. How this equation came? Considering summation of force in x direction. Now similarly, you can consider summation of force in y direction 0. Summation of force in y direction means, what are the forces acting in y direction? One is this f of qr cos 60 and then w. Okay. So f of qr cos of 60, and the next force will be minus of w is equal to 0. So can I write f of qr is equal to w? What is the cos 60 value? 1 by 2. So this value will be 2w. This value will be 2w, and this is coming out to be positive, means this is a tensile. Similarly, from the first equation, can I write f of pq is equal to minus, f of qr sine of 60? What I have done, I have taken this f of pq in this side. So f of qr sine 60 is equal to f of pq. And you know already the qr value. What is the qr value? 2w. And what is the sine 60? Root 3 by 2. That means what is the value you are getting? Root 3w. So now you can check which option will be the matching with our answer. So f of pq you are getting as a 30w, and f of qr is the 2w, and both are coming out to be positive. That means whatever the direction which you assumed, that will be the correct. Now if you see, this member is trying to compress this joint. Okay, so if you consider this member, what is the force? Equal and opposite. So this is the member only. I'm talking about this member. If this is the force, same force will act on this member. So what is the what type of force is this one? This is compressive only. So this root 3w is nothing but compressive. Root 3w is nothing but compressive. So always focus on the joint, calculate the force in the joint only, then you just draw the member. This is the member. If this is the force which is acting in the joint, so same equal and opposite forces will act here. So what is the force here? This force and this force. What is the force? This force is nothing but f of pq. And if you see, this force is trying to compress this member. That's why it is a compression. So what is the correct answer? F of pq is getting as root 3w, which is compressive. Okay. Uh, and 2w, which is tensile. So let me check. F of qr value you are getting as a 2w. And what is the qr? This is basically a compressive, and this is basically a tensile. Why? Because this is qr. This is qr, not pq. Here should be qr, because this member I am talking about. So f of qr is nothing but a compressive. So this is a compressive. If you see here, this member is trying to pull the joint. That means f of pq is coming out to be root 3w. Suppose again what you will do? This is the member. If the joint is force is acting like this, same force will act like this. So what are the forces acting on this PQ member? This PQ member is tensile. So root 3W is tensile. That means what is the correct answer? So root 3W tensile, you have to write down PQ first, QR. PQ is root 3W tensile and 2W will be compressive. That means choice B will be the correct. So in every question of trusses, what you will do, you just consider the joint, calculate the force in that particular joint. Now, whatever the magnitude you are getting, that will be the correct. But for direction, what you will do, just see the joint only. F of QR is this direction. That means if you consider the member, equal and opposite force will act. This is compressive. Yes, you are getting. Now you can write compressive. For example, if you consider this member, this force is trying to compress, tensile, or we can say that the pulling this joint F of PQ. So same opposite force will act, because if this is trying in this direction, so the member force will be in this direction. So F of PQ you will get as a root 3W tensile. Okay. So more than 6 to 7 problem I have discussed. Now, how to solve the problem related to the based on the method of section. Okay, first of all, I will discuss what are the various steps you have to follow in case of method of section. Then we will solve some problem. The first part will be same in method of joint as well as method of section. That means you have to draw the free body diagram, whatever the reactions are acting on the joint. For example, this is the truss structure and this is the supports. You have to apply the reaction and calculate the reaction. That will be common for both of method of joint as well as method of section. That's why I mentioned, consider free body diagram of entire truss and calculate the support reaction by using the equilibrium equation. Okay, so this part will be common. Now the next is, cut the truss into two equal parts such that it should not cut more than three unknown member. Okay, so if any truss member is given, for example, if this is the truss member, so you have to cut the truss into two parts in such a way that the three members are cutting. Okay, then after that, select any one of the two parts. Either you can consider the right hand side or left hand side by considering the forces acting on that part only. So if you are considering right side part, that you have to consider the forces on the right. If you are considering left side, that means you have to consider the left side forces. Then assume tension and compression in cut member. That means same thing, like whatever the forces which is acting on the member, either it is a tensile or compressive. Now the last step is, do not consider the effect of uncut member. So whatever the members which you are not cutting, that you not consider by calculating the forces. Okay, once I will discuss one problem, then you will understood. So let's see, try to solve this problem by method of section. Okay, so same problem you can solve by method of joint also. But the problem is, what is the question? For the truss as shown in figure, the magnitude of force in the member SR. That means you have to calculate the force in member in this one. Okay, so how you will proceed? Suppose if you want to calculate by using the method of joint, okay, so you will apply the reaction here. Then you have to calculate the reaction. What is the reaction at P point and Q point by using the equilibrium equation? Once you know the reaction value, then you will consider this joint. You can calculate this force and this force. Then you will move to this joint. Then you will reach at this point. But the advantage of method of section is, you can calculate the force in any intermediate member without calculating the force in other member. That means if you want to calculate the force in SR member, just cut this cross section or cut this trusses into two half from this point. One member is this one, which is cutting. One member is this one member is this one. Now, I will consider this part only, because this is only one force will act here, because there you have to consider the two. One force is the 30 Newton and another will be the reaction. So I will take the right hand side part. You can take the left also, no issue, but calculation will be little bit more, because you are two reactions and one force. But here only one force will be there. Okay, so I have cut this this truss from this point. SR member I am cutting, RT member I am cutting, and TQ members I am cutting. Okay, so there are the four options. But before that, you have to calculate the reaction. That's why I mentioned clearly, you have to calculate the reaction by considering equilibrium equation. And that is the common for method of joint as well as method of section. Okay, so you already know how to calculate the reaction. For example, there is a hinge joint. What are the reaction will act? One is the reaction in the upward direction. Let us suppose this is RP vertical, and there is a RP horizontal, and this is the RQ vertical. Okay, so two reaction at the hinge joint. One is the roller joint. Now you can easily tell this value will be zero, because there is no horizontal force. If there is no horizontal force, it will automatically zero. Or how? If you consider the summation of force in x direction, yes. So only one force is acting in the x direction, and that is equal to 0. Now you have to calculate the reaction at this point, that means P point and Q point. What you will do? You will consider summation of force in y direction 0 and take the moment about any point, this point or this point. Okay, just consider second equation is summation of force in y direction 0, and the third one is summation of moment about P point is 0. Okay, so always I am using the three equilibrium equation. So you can calculate the RPV and RQV by considering these two equilibrium, because two equations, two unknown, you can easily solve. So can you please tell me what is the RPV and RQ value? Yesterday I have discussed more than 3 to 4 problems. In every problem, you have to do the first of all reaction calculation. Do it fast. Just apply the equation in vertical direction. These two forces is equal to 30, and take the moment about this point and tell me what value you are getting.
Sir, sir, sir,
Yes.
sir. Regarding this previous question, I have a doubt, sir. In that, sir, the force PQ, sir, which is acting at the top horizontally, sir. When I draw that, when I draw those forces here, sir, why this FP here? Why I need to draw this FPQ to the leftwards, sir, rather than rightwards?
This one, you can consider the right word also. If you consider the right word, then you will get this FPQ is automatically negative. I have told you, no, you can consider in any direction. You can consider in this direction, this direction. Once the answer you will get, that will clearly indicate your assumption. That means the direction, whatever you have assumed, that is correct or not. For example, if you are considering this direction, okay, so this is positive. Here it will come positive. F of PQ is positive, and f of QR sine 60 is also positive. That means f of PQ is equal to minus of f of QR sine 60. Yes or no? That means f of QR you already got 2W. That means this f of PQ you will get as a 2W value. Then you can easily solve. Then you will get this f of PQ root 3W. That means either you can assume in this direction, this direction. It doesn't matter. If you are assuming in this direction also, whatever the answer you are getting, then you check you are getting as a positive or negative. If you are getting as a positive, your assumed direction is correct. If you are getting negative, that means whatever the direction you have assumed, that you can reverse. The same thing I have discussed in the previous question also, no? Yesterday.
I got it, sir. And the second thing here is, sir, okay, sir, and when you, as per this diagram, which is at the top left, sir, I can use Lami's theorem also for this question.
Yeah, yeah, you can use the Lami's theorem also, not a problem. But the thing is, the three forces should be at. When you are resolving these forces, either you can solve by the generalized approach or by using the Lami's theorem. Okay, so for example, this force is acting, this W force is acting, and one is F of QR. And you know the already the angle value. This is 30 degree. You just apply the Lami's theorem because one is known to you. You can calculate. There is not an issue. That means in method of joint only you can use the Lami's theorem. But only three forces are acting, then you have to see. Here three forces, definitely you will get the correct. Got it?
Yeah. Okay, sir. Three, four, sir. So here, okay. If I use Lami's theorem also, I will get the answer itself, this FPQ.
Yeah, you can check. You can check with your own. Definitely you will get. Because the Lami's theorem says when three forces are concurrent and coplanar, then you can write down the force divided by sine of whatever the angle made by the other two forces. Definitely you will get. But this generalized method is summation of force in x direction, y direction. Because in every question you are doing, for calculating the reaction also, for calculating the force in intermediate member also. So if you have a practice more on this format, then you can easily solve. Then there is chances of mistake will be less. But if you are okay with the Lami's theorem, try to solve. Okay, now
Yes,
please
sir.
tell me.
Because
Yeah,
thing
yeah,
is, if I use Lami's theorem, I can solve it quickly and accurately.
yeah. I told you, no. Whenever the three forces are acting, that is concurrent, try to use Lami's theorem. That is not an issue. You will get the answer same. Okay, for this question, just tell me what is the reaction at P and Q point.
Sir, regarding this question also, I have a doubt, sir. At the point P, sir, there are two reactions. One is the horizontal reaction and another one is vertical reaction, sir. Sir, the thing is, sir, the direction of these reactions are pointed towards that hinge only.
Hmm. Going towards the hinge only, no? When the vertical force is acting here, how you will balance this force? You have to consider the reaction in the upward, no? Again, if you use the equilibrium equation, for example, this value is coming out to be negative. That means you just assume, reverse this direction. Same thing. If you are using the equilibrium equation, just assume any direction. But by using the common sense also, you can say, no, if the load is acting here, for supporting this load, the reaction should be in this direction. No? For example, if you are taking RPH in this direction, there is no meaning. Why? Because there is no force. There is no force means RPH is zero.
Yeah, got it, sir.
So please tell me, what is this vertical reaction? Just consider f of summation of f of y 0 and take the moment about this point. Do it fast. What is the reaction at the P in the vertical direction and the Q direction? Only two equation you have to use. Very simple. If you got, just mention in the chat box. What is the value of reaction at P in the vertical direction and Q? Very simple, no? You are taking this much time. RPV plus RQV is equal to 30. This is the first equation. Now, if you take the moment about P point, what are the forces which create the moment? This force and this force. So RQV into what is the distance from this point? 3 is equal to, because it is creating a anti-clockwise. So there is a clockwise moment of 30. So 30 into 2, that means RQV value you are getting as a 20 kilonewton. 20 kilonewton RQV you got. What is the RPV? 10 kilonewton. Okay. So you calculated the reaction at P point and the Q point. Now, now the next thing is how you will calculate the force in this member. Okay, so the first step we already did. Now you have to cut the trusses into two parts. Okay, so now I'm cutting the trusses into two parts. Select any one of the part. I will take the left part or right part according to my convenient, in which the calculation will be very less. Then, assuming tension and compression, whatever the direction, either you can consider in this direction, and do not consider the effect of uncut member. So whatever the uncut members are there, please do not consider those parts. Okay, so I have taken a cross section, or I am cutting this trusses from this point. The three members are cutting. Now, suppose if I will cut from here, so I will take this part only. What are the forces acting? The forces are nothing but this is the one member, and this is the cut member, and this is also a cut member which is meeting actually at this point, and this is also at a cutting member. Okay, so I have cut it from this point, this section. So I'm taking the right hand side portion. So what is the reaction at this point? You already calculated. So this is nothing but the force in member QT. Okay, this member. Okay, now this is nothing but force in member RT, and this force is nothing but in member RS. Now, you know this is the reaction. What is the reaction value? Our QV is 20 kilonewton. If you know the 20 kilonewton here, can you calculate the force in member these two? Very simple. Summation of force in X and Y direction. If you take summation of force in Y direction, so can I write? You can calculate the force in this point only. But where you have to calculate the force? You have to calculate the force at RS. So why you will calculate the force in this member? Because you already have one more equation, which is moment about any point zero. So for example, if I will take the moment about this point at T point, that means summation of moment about T point is zero, your problem is solved. Why? Because these two forces are passing through the same point. Only this force is creating a moment and this force is creating a moment. So in that manner, you can easily calculate. So if you take the moment about this T point, f of rs into this distance. What is this distance? Yeah, this is given as 1 meter. What about this one? This is also a 1 meter. 1 meter. That means f of rs into 1, which is anti-clockwise, and plus 20 into 1 is also anti-clockwise, is equal to 0. That means what is the value of f of rs you are getting? Minus 20. So minus 20 is indicating your assumed direction is wrong. That means this negative is indicating this value will be 20 kilonewton compressive. 20 kilonewton compressive. So what is the force in QRS member? 20 kilonewton. That means option C is the correct. And this is the beauty of method of section. Without calculating the force in this intermediate member, you directly calculated the force in this SR by using the equilibrium equation. If you want, you can solve by using method of joint also. Consider this joint, calculate the force in member this point. Once you know the force in member this point, then you have to consider this joint. So these three forces, these three members are there. So the remaining two also you can calculate. So the method of section will help you the force in any intermediate member without considering other member. Okay, so directly you can calculate. Okay, one more question I will discuss so that you will get some confidence. So, but before that, read this question carefully. For the truss as shown in figure, the force F1 and F2 are 9 kilonewton and 3 kilonewton, respectively. The force in kilonewton in the member QS. So you have to calculate the force in member QS. So you have to calculate the force in member QS means, can you take the cross section like this? Because three members are cutting, so you can take the right hand side or left hand side. Take the right hand side and the left hand side. Or if you take this particular section, this F1 force is known to you. Without calculating the reaction also, you will get the answer. Okay. So now These are the four options. So let me take, yeah, I have already taken this subsection, which is nothing but 1, 1. Now, if I will take this left-hand side portion, what are the forces acting? F1, and this member force is PQ, okay, which is meeting at Q point. And if you cut it these three members, so one more force will come here, FSQ, and this member is also FST. Okay. Now this point is S and this point is P only. This distance you already know, 1.5 and 3 meter. What you will do? You will directly use the summation of force in y direction. Why you are using the summation of force in y direction? Because you want to calculate the force in SQ. If force in SQ means if you resolve this force in the vertical and horizontal direction, what is this force? Can I write this force is F of SQ sine of 60? Because theta is making here. So this will be cos 60. F of SQ cos of 60. Now what you will do, you just consider the equilibrium equation, which is nothing but summation of force in y direction 0. What are the forces acting in y direction? One is the F1, another is the FSQ sine theta, okay, and FST, and these forces are in the horizontal. So right now I am writing the equation in y direction. So F1, which is negative because it is acting in downward, plus F of SQ sine of theta is equal to 0. You have to calculate the force in SQ member only, no? And F1 you already know. So if F1 is known to you, which is nothing but, let me take, yeah, 9 kilonewton is given. F2 is 3 kilonewton. So 9 kilonewton value is known to you. This is 9 kilonewton. So if you calculate this theta value, your problem is solved. That means in this problem, you have not calculated the reaction. Directly you solve the problem by using method of section. Why I have take the section from here? Because I want to calculate the force in member QS. So that means this member has to be cut. That's why I have taken this as a cross section. So then you can consider the left side portion. So let me calculate what is the theta. So this is basically a triangle. What is this height? Can I say this height will be 2 meter? Yes, which is given. This total will be 3 meter. This total will be 3 meter. What is this distance? This distance half will be 1.5. Yes or no? So space is less. Let me use some different color. Yeah. This one is 1 point. Just removing this part. 1.5 meter. 1.5 meter. So sine theta, can I write? Sine theta, can I write? Or otherwise, I want to calculate the theta value, no? So, but perpendicular and base value I know. So tan theta can be written as 2 divided by 1.5. So from here, theta value you will get as a 53.13. Once you know the theta value, so sine of 53.13, if you calculate, you will get the answer. Can you please tell me what is the answer for this 9 by sine 53.13? What is the value of f of SQ?
Sir, it is 11.25.
Very good. 11.25 kilonewton. Okay. Now this value is coming out to be positive, and f of sq, if you see, this is nothing but a tensile only because you are pulling this point. Suppose if you will draw a member, if this is in tensile in nature, so if you same equal and opposite, if you will apply for this member, what is this force? Tensile. That means 11.25 tensile. So there are the four options. Now you see the option A and option B value are same, but the sign is different. That's why I told you focus on the sign also. That means you only have to calculate the force in member joint. Once you got the value anything, for example, in this direction, just draw a member like this. If this is the force in this direction, so same equal and opposite force in this member. So it is trying to increase the length of this member or tensile in nature. So the answer will be 11.25 tensile. That means what is the correct answer? The choice A will be the correct. Choice A is the correct. Okay. Is it clear?
Clear, sir.
Now there are the third type of problem. Okay, so again I'm telling you, you can use the method of joint also, method of section, but method of section will help you directly calculate the force in member. Now the third type of question they are framing, how many member having zero force? How many members having zero force? So how you will calculate the zero force member? First of all, what is zero force member? Zero force member is nothing but so zero force member means so zero force member means those member which not subjected to any kind of axial load. So a member which is subjected to not subjected to any type of axial load. Any type of axial load. That means the force in that member will be zero. Okay. So why we are using the extra member if the force is zero only? To maintain the stability. Okay. So that is the advantage of this zero force member. Why we are keeping more members? To maintain the stability. That means to increase the stability, increase the stability of trusses. So that if any circumstances like wind force or something which is acting, so it will not disbalance. That's why you are providing the extra forces, extra member. So now how you will identify to zero force member? So there are some special conditions which I have already mentioned in my live classes also. So again, I am just quickly I am revising how to identify the zero force member. So the first point is if at a joint, three members are meeting, out of which two are collinear, then the force in the third member will be zero. What it means? For example, at this particular joint, three members are meeting. So let us suppose the force in that member is F1, F2, and the another member is nothing but the force in member is F3. Okay. So these are the force in the member. Let us suppose one member is this one, another member is this, another member is like this. So out of these three member, out of which the two members are collinear. That means out of this three member, if two are collinear, then the force in the third member will be zero. How it will zero? So if you consider at joint O point, joint O point, just one at joint O point, if you consider, so what are the forces? Let us suppose this is the angle theta. Okay. These three members are acting like this, out of which two are collinear. Then the force in the third member, I am telling it is zero. So I'm just proving how this will be zero. This is F3 force. Can I resolve this force in X and Y direction? Yes. So this force will be F3 sine theta F3 cos of theta. Okay. Now, if I will write down the equilibrium equation in the y direction, summation of force in y direction 0, that means this direction. What is the force acting? F3 sine theta is equal to 0. If F3 sine theta is equal to 0 means, you know already the sine theta cannot be 0, because if this member is acting, if the member is constructed in this manner, there should be some theta. For example, it may be 30, it may be 40. So this theta cannot be 0. So sine theta cannot be 0. So sine theta cannot be 0. So if these two values is 0, that means the F3 should be 0. This is very important condition. The first point I have discussed, please remember, it will help you to identify the zero force member. Once I will discuss the problem, then you will appreciate. So this three members are meeting at a joint, two are collinear, then the force in third member directly you consider as a zero, provided that there is no force which is acting in this direction. Why? Because if there is any force, if you write down the summation of force in my direction, F3 sine theta will come. Let us suppose this is 50. So plus 50 is equal to 0. That means F3 value, you will get some value. So if there is no force which is acting at this joint, three members are meeting, two are collinear, force in the third member will be 0. Okay, this is the first point. Now the second point is, if at a joint, two members are meeting which are non-collinear. Okay, so at this particular point, if two members are meeting, they are non-collinear. Non-collinear means they are not lie in the same line. Then the force in both the member are 0. Always remember, then the force in both the member are 0 if there is no load and reaction at the joint. That means this condition will be applicable in the first part also, which I have discussed. Let me take, if there is no space, we take first this one. I have already mentioned, but if you make a note. Yeah. If there is no load or reaction at that joint, that means there is no load and the reaction. Because if there is a value, that means F3 cannot be 0. Now, what is the second point? If at a joint, two members are meeting. For example, this joint, two members are meeting like this, F1, and this will be the F. Okay, they are making an angle of theta. Two members are meeting, there is no force which is acting at this joint. Because if there is a force, if you resolve, then you can easily calculate F2. But I'm telling, if there is no force acting, force in both the member will be 0. How? For example, if you consider, just to resolve the F2 force in this direction, what is this value? F2 cos theta. And this value is F2 sine of theta. So if I will write summation of force in y direction 0, F2 sine theta value is 0. That means sine theta cannot be 0. So F2 value should be 0. F2 value you are getting as a 0. So if F2 is 0, if you consider summation of force in x direction 0, F1 plus F2 cos theta is equal to 0. These are the two forces. So F2 is 0. That means F1 is also 0. Very, very important point. So 2 points I have discussed. When two members are meeting, okay, out of which they both are not collinear, if there is no load acting at this joint, force in both the member will be 0, which is coming out 0 only. If three members are meeting, out of which two are collinear, then the force in third member will be 0. Now the next point will be, if two members are meeting at a joint which are non-collinear, okay, which are non-collinear, but external load is acting at that joint. External load is acting at that joint. What it means? What it means, for example, two members are meeting. Let us suppose this is F1 and this is F2. They are meeting at this particular joint, and which is making angle of theta. Okay. Now at this joint, I have taken no force or no external load. Now, if I am considering there is an external load, let us suppose this is 5 kilonewton. Because I mentioned, but external load is acting at the joint in direction of one of the member. So in this direction, one force is acting. Now, the force in other member is 0. That means this force in this particular member is 0. Yes, you will definitely get, if you resolve this force, what is this force? F2 sine of theta, F2 cos of theta, F2 cos of theta. Now, if I will write down summation of force in y direction 0, so F2 sine theta is 0. That means F2 will become 0 because sine theta cannot be 0. If you write down summation of force in x direction 0, So f1 plus f2 cos theta minus 5 is equal to 0 because it is acting in this direction. So f2 is 0, that means this value will be 0. So f1 you are getting as a 5 kilonewton. That's why I have told, if two members are meeting at a joint which are non-collinear, they are not collinear. If they are collinear, that should be lie in the same line. But external load is acting at that joint in the direction of one of the member, then the force in other member means this member, f2 value will be 0. Okay, so please make a note of these 3 points. Then I will discuss the problem. These 3 points will definitely help you to identify the zero force member. Because the other method is you have to consider method of joint, calculate the force in every member. But sometimes if you remember these 3 points, then directly you can find the force in this member will be 0 or not. Okay, so please make a note of these 3 points. Then I will discuss problem.
Sir,
Yeah, Raj.
so till now what you have just now what you have told or discussed this present topic I didn't understood, sir.
You didn't understand. First you tell me.
Means this is a means here in the present slide, sir. What is the thing, sir? Means I have to here means if three members are acting, then what I have to do and means
First you read the statement what I have written. You have to identify how many zero force member are there. Okay. So I have given you the three special condition that will help you for solving the problem. Okay, what is mentioned? If at a joint, three members are meeting out of which two are collinear, then the force in the third member will be 0. That is the first condition. And how it is coming 0, I have discussed already. Just resolve the forces in the y and x direction. If you take the summation of force in y direction, F3 value will be 0. Now the next thing is, if at a joint two members are meeting, out of which they are non-collinear. These forces are non-collinear. Okay, this is the part of any particular trusses. Suppose these trusses are acting like this. Okay, there is no load. Then you have to use this condition. When I will discuss the question, then you will understood. But you have to remember this condition. If at a joint two members are meeting, which are non-collinear. Yes, they are not collinear. Then the force in both the member will be 0. So force in F2 and F1 is 0. How you are cutting? Now how you are getting this? Just take the summation of force in x direction and y direction. Summation of force in y direction means F2 sine theta is equal to 0. Sine theta value cannot be 0. Why? Because these members are acting at some angle. So if they are acting at some angle, theta value it may be 30, it may be 40. So sine theta cannot be 0, F2 is 0. If F2 is 0, if you consider summation of force in x direction, you will get F1 also 0. Similarly, you can identify for the third condition. If two members are meeting at a joint which are non-collinear, yes, but there is an external load is acting. In this case, there is no external load. But if there is an external load is acting, then the third condition says the F1 will be equal to 5 kilonewton and the force in the other member will be 0. That means in which direction the force is acting, that member having the same force, but the force in other member will be 0. So these are the three special conditions to identify in the case of truss how many members having 0 force. Now is it clear?
okay, coming to understood, sir.
Please make a note of this. Once I will discuss one or two problem, then you will appreciate like how I use these conditions to identify the zero force. But I have discussed in this thing in my live classes also. Have you attended those classes?
Hmm. Yes, sir. Okay, sir. Show me next slide, sir. Okay, sir. Another slide. Next one. Yes, sir.
Now come to this particular question. What is the question? The figure shows a pin jointed plain truss, okay, is loaded at point M. That means there is a load which is acting M. The member ln of the truss is subjected to load. Okay. Now you see you have to calculate what is the force in this member ln. Now you just check, did I have discussed any special condition? Because if you consider this joint, three members are meeting, out of which two are collinear. Out of which two are collinear. Then the force in the third member will be zero. That's why I told you, if you remember those special conditions, you can easily identify the force in the member ln value will be zero. What is the correct answer? Okay. Did you understood? What is the first condition? Read the condition first. The condition is, if at a joint three members are meeting, two are collinear, then the force in third member will be zero. It may be acting this manner, this manner, this manner. How it is coming? I have proved that one. So similarly, you can tell the force in this member will be zero. Or you can also understood. Just consider the joint L. If you are considering the joint L, let us suppose this is the force Lm, this is the force Kl, and one more member is there. Let us suppose this force is acting as a F of Ln. So if you take the summation of force in y direction, what are the forces acting in y direction? Only Fln, which is equal to zero, because there is no force. If there is a force, then there will be a value. So you can easily identify. That's why I told you, please remember those special conditions. Is it clear?
Sir, so it means here presently what you told, I didn't understood it clearly. Now, in according to this question, sir, there's a mass of 100 kg is acting at the point M in this truss, sir.
Mm,
So it will show effect on this on KM, KN, LN, MO.
mm.
So
So,
here the
so either you can consider the method of joint, calculate these forces. So what is the purpose of studying? You can save your time, no? That's why I discussed the special condition. Once you will consider this joint, just resolve the forces. You will get some value. But you want to calculate the force in this member. What is the special condition? If three members are meeting, out of which two are collinear, one is non-collinear, the force in third member is zero. Then why you will check what is the force in Ln, what is the force in Lm? If you want, you can calculate. Understood? You have to identify the force in the Ln. What is the special condition? If three members are meeting, out of which two are collinear, that means the force in member Ln is zero. If you want, you can check with this one also. What is the method of joint? This joint you will consider. This force will balance with this one. Which force will balance this? No one is the force which is acting. So automatically the Ln force is zero, no? Got it?
okay, understanding, sir.
Means
Okay,
you are not
means here
revising. This is very simple basic thing I have discussed. More than 7 to 8 problem I have discussed already. You just consider this joint. Okay, method of joint, what you are doing? You are just balancing the forces. This force is balanced with this one. Is there any other force which is acting here? Automatically this force will be zero, no? And that you have to calculate. And what is the answer? Fln is equal to zero. But still no need to use this one, because if you remember this special condition, directly you can tell, okay, sir, this is the force, Ln value will be zero. For example, if I will ask you the next question, now you see how many member having zero force. What you will do? You will use the method of joint in every question and calculate the forces. It will take more than 5 to 6 minutes. Then you have to use the special condition. Did you understood? They are framing the question. What is how many member having zero force? How you will identify? You can calculate by using method of joint also. Consider this joint, calculate the force in these two member, then proceed here, then proceed here, then proceed here. But if you remember these three cases, automatically you will get the answer. Is this question is clear? Force in the Ln value is zero.
okay, sir.
Now, what is the question? A figure shown an idealized plane stress. A horizontal force of 300 Newton is applied at a point A. That means the force is acting at A point. The magnitude of force member in CD. Okay, you have to calculate the force in member CD. How you will do? I have discussed the three condition. Just tell me which member having zero force. Read the first of all, read the condition. You have taken already, I think, a screenshot. Read the condition and tell me either it is matching with the first condition, second condition, or third condition. It is the first condition. Three members are meeting, two are collinear, force in the third is zero. So which member having zero force? For example, if you are taking this joint, how many members are meeting at this joint? Tell me.
3, sir.
So which are those three?
AB, BD,
Yeah.
and BC.
Okay. So out of which is the two are collinear?
Which
Which two
are
are
out of
collinear? Out of these three member, which are collinear? Which members are collinear?
B and BD.
AB and BD. Okay. So if these two are collinear, three members are meeting. Can I say force in member BC is zero?
Yes, sir.
It is this. I mean, that is the meaning of special condition. Okay. So this force is zero member. Again, just move to the C. How many members are meeting now? This is already zero force member. Now you just tell me how many members are meeting?
3, sir.
Three. So AC and CE again they are collinear, no?
Yes,
Yes
sir.
or no? So force in
Yes, sir.
member CD value is zero. Did you find any mistake? Is there any use of 300 Newton? If you want, you can calculate. Consider this joint, calculate the force in this member, then move to this point, then move to this point. Again, you will get the answer. There are some special conditions, there are some assumption you have to remember to make the question easy. So the force in member DC is zero. Okay, for example, if I want to calculate the force in member DE, can you please tell me what is the force in member DE? Consider this D joint. How many members are meeting? One, two, this is three. Again, these two are collinear. Again, this force in this member will be zero. Similarly, the force in member in this. Now the question is, you have to calculate the magnitude of force produced in the CD is coming out to be zero. But they can ask how many member having zero force? Four. Did you understood how the question they can frame? The
Coming to understand.
force in member CD you have to calculate. Suppose in this same question, if I will ask you how many member having zero force? So how many member having zero force?
4, sir.
Four. That means they can frame the question in this manner also. If you want, you can proceed method of joint. Just take this cross section, take this joint, calculate the force in this point. Because 75 and 75 is given. You can calculate this angle. Once you know this angle, calculate the force in this member. Then you have to move this one. Then you have to move this one. In the similar manner, if you proceed, then you will get the force in this member. But if you remember the condition, if three members are meeting, out of which two are collinear, then the force in third member will be zero. So the force in CD member will be zero. And this question was asked in the, I think, GATE 2017 or 18. Okay, so one more question I'm asking that will help you. So this is the question. Okay, a truss is composed of member AB, BC. That means this is AB, BC, CD, and AD, BD. Okay, as shown in the figure, a vertical load of 10 kilonewton is applied at D point. Okay, the magnitude of force in the member BC you have to calculate. What is the magnitude of force in member BC? What we will do? First of all, you will consider the equilibrium equation and you will calculate the reaction. What is the reaction at A and C by when you are applying the 10 kilonewton load? So at least this thing you can do. Do it fast. Read the question carefully. You have to calculate the force in member BC. 10 kilonewton is acting here. Okay, so what is the reaction here? RA horizontal and RA vertical. Here will be RC vertical. Calculate these reactions by using the equilibrium condition. Summation of force in X, summation of force in Y, and take the moment about any point will be Z. Read fast. Tell me what is the reaction first. This is the condition. 10 kilonewton is acting. Calculate the reaction at A and C. More than 10 problem I have discussed. The first step is calculating the reaction. So I just want what will be the reaction at A and C. Okay, so take your time. Please tell me what is the reaction at the point A as well as C.
Okay, sir. Show me the previous slide, means the question where it is. Okay, sir.
You got the answer? This is very simple, no? You only have to calculate the reaction. If you use your common sense also, you can easily identify. The load is acting at the center, at the center point. If this 10 kilonewton load is acting, what is the reaction at A and C? 10 kilonewton load is acting here. What is the reaction at A and C? one vertical load which is acting at center, it will be equally distributed. No, this is 5 kilonewton, this is 5 kilonewton. Why are you taking this much time? And this value will be zero. What is RAH? RAH value will be zero because there is no horizontal force. There is no horizontal force. This is automatically zero. Whatever the vertical force is there, that 10, it will be equally divided because it is acting center. Very simple, no? This is a beam. If the 20 kilonewton load is acting and there is a support, so 10 will be here, 10 will be here. Symmetrical loading. Or if you want, you can calculate the summation of force in y direction. Take the moment. Okay. So the force in the member, which member you have to calculate? The force in member BC you have to calculate. What you will do? That means you have to calculate the force in member, this portion. Then what you will do? You will consider the joint C. Consider joint C. This consider, this one is joint C. This angle is 45. So let us suppose this is 5 kilonewton. And this is the force in member BC. Okay. Let us suppose this F force in member CD. And this is 45 degree. Okay. What you will do? You will resolve the forces. F of CD sine of 45. And this one is F of CD cos of 45. Okay, what I have done, I have resolved these forces here, but the space is not here. That's why I have written here f of CD sine 45, f of CD cos of 45. Then what you will do, you will write down the equation summation of force in x direction 0 and summation of force in y direction 0. So in every question, I am doing the same thing. Summation of force in x direction means f of BC plus f of CD cos of 45 is equal to 0. Now, if you take the summation of force in y direction, f of CD sine of 45 plus 5 is equal to 0. Can I calculate FCD value? Minus of 5. Sine 45 is 1 by root 2. So this will become 5 root 2. 5 root 2. F of CD is equal to 5 root 2. This is compressive. This force is compressive because negative sign is coming. Now, if you put this FCD value in this one, you can calculate the force in BC also. Force in BC from this, let us suppose, first equation, you will get as minus of FCD cos of 45, and FCD is minus 5 root 2. So 5 root 2 into cos 45 is 1 by root 2, and this will be 5 kilonewton. That means the force in member BC is 5 kilonewton. And that you have to calculate. Magnitude of force in member BC. So in this force in member in BC will be 5 kilonewton. Suppose the same question, if I am asking you what is the force in member BD? What is the force in this member BD? Can you tell me what is the force in member BD? Just recall the special condition. What is the force in member BD? Are you there, Raj? What is the force in member BD?
Sir, it will be 0, sir.
Zero only, because three members are there which is meeting at a point, out of which two are collinear, then the force in third member will be zero. See, without lifting a pen, you easily find the force in member is BD. So sometimes they are making a question like that also. But if you want, you can calculate also. This point, if you consider, suppose if this joint you are considering the force in member BC, let us suppose this force in member AB, and this is, let us suppose, force in BD. Now, this force will balance this one if you take the summation of force in x direction. What is the force acting in y direction? Only BD. So it will come out to be 0. That means if you use this special condition, directly you will make it as 0. If suppose, if I will see this question directly, I will make this as a 0 force member. Why? Because three members are meeting, out of which two are collinear, then the force in third member will be 0. And this is the GATE 2019 question. But you have to calculate the force in BC member. So very simple, take the summation of force in x and y direction. or whatever the force which is acting at the center point, it will equally distribute 5 kilonewton, 5 kilonewton. Once you know the reaction, just write down the equilibrium equation for the joint C, you will get the force in BC. Okay. Now, one more example which I have made, you have to calculate the zero force member. Okay. What you will do, you will start from this portion first of all, and tell me, is there any special condition which is matching with this, or which portion having a zero force member? So let me give the name. This is A, B, C, D, F, G, H, I, J, K, and L. And this question I made, you have to calculate how many member having zero. How you will identify? Recall these three conditions. So these three members are meeting at a joint, out of which two are collinear. So which member having zero force?
Sir, 6.
Okay, so you find the answer also. Okay, let me check, cross
1,
verify.
2, 3,
Maybe
4.
maybe you missed
No, sir,
some
4.
member. Yeah, there is a hidden part. That's why I made this question. Why you are telling four? I will tell you. Why you made little bit mistake, but I'm very happy you understood the condition. Okay, so these members are meeting at a joint. Out of these three, two are collinear. Okay, so you told, I think this member having zero force. Yes or no?
Yes, sir.
I think you counted
Next,
this one. Next one is
JF,
JF. Very good. Then next one is
HK.
HK, and the next one is you told LH. Yes or no?
Mm.
Okay, so four member you have counted. Now, if you see the question carefully, if these two are zero force member, and again if you consider this joint, three members are meeting. Can I say this member having zero force member?
Yes, sir. Okay.
Okay. Then what will be the next one? Proceed in that manner.
CG,
Very good. CG. Then next one.
DF.
Very. That means how many number of member having zero force? Total seven members having zero.
Mm. Okay,
That
sir.
is the beauty of this three node point. That will definitely help you. So if you don't know this condition, no, you will calculate. You will calculate first BC, AB, then you will calculate this one. For example, in this question, they will mention what is the force in BD. If you are my student, directly will tell, sir, force in member BD is zero because three members are meeting, and out of which two are collinear. So the force in third member will be zero. Then you will move to the next. No need to calculate. Why you will waste your time? Save your time. Then you can apply that time to the next question. Okay. So now this is the about the trusses, the method of joint, method of section, and the third type will be zero force member. So today I have to discuss one more important topic, which is nothing but how you will calculate the force related to wedge. Yesterday you have asked, I think. So before that, I just want to briefly discuss the friction. What do you mean by friction? Friction is nothing
Sir,
but it is a, yeah, tell me.
it is an opposing force which acts on a body, or any surface, or or in any certain portion of a body when that body is moving in a direction, sir. Moving in its
Okay.
favorable direction.
Okay. So can I say the friction is a, basically it is a type of force which will tangentially act to the surface and it will retard the motion. Which motion?
Yes, sir.
Relative motion. For example, this is the block which is resting over this surface. Now I am applying some force. Okay. This surface having some coefficient of friction. What will happen? This surface will try to resist this force. What is the force? The force is nothing but the friction. So there is a relative motion because this surface is at the rest and it is moving. It is moving with some velocity. So whenever there is a relative motion, then the friction will retard their motion. Friction will retard their motion. So I think there is a no need to write the definition. So friction, I will write in a simple format. It is a force, or it is a resisting force which acts at the plane of contact, at the plane of contact plane of contact, plane of contact, and the motion between the surface or between the, I will write, and the relative motion between the surface is retarded by force that is called as a frictional, that is called as a frictional force. That means it is a kind of resisting force which act at the plane of contact, and the relative motion between these two surfaces, it can be resisted or retarded, that is called as a friction force. That means it will try to oppose the relative motion. Now, there are some important terminology. The first one is the friction angle. What do you mean by friction angle? For example, this is the block in which the force P is acting here. The W will be the weight of this body. So if it is making a contact with the surface, that means there will be a normal reaction. So if this block is moving in this direction, the frictional force will act in this direction. Okay. That means the frictional force and the normal having a resultant force, this one. Okay. So the friction angle is nothing but the angle made by the resultant of the frictional force and the normal reaction with the normal part or with the vertical. So the resultant force of this friction and normal reaction making with the vertical is called as a frictional angle. So I can write the 10 phi value is nothing but F max divided by normal reaction. Because if you consider this is the F max only, this is the vertical. So if I will consider 10 phi, the perpendicular divided by base, that means F max divided by N. What is the F max value? You know that maximum value of friction is coefficient of static friction into normal reaction. That means the phi value you can calculate as 10 inverse of mu s. Why this is important? Because sometimes they will give you the coefficient of friction, or sometimes they will give you the friction angle, then you have to calculate the mu s value. Okay, so sometimes most of the time they are giving the mu s value directly, but for example the friction angle they are giving as a 30-degree, then just take 1030 value is nothing but the mu s. Okay, so this is the first one. Now the second is angle of repose. What do you mean by angle of repose? If a body is resting on an inclined surface, then the angle of repose is the maximum angle at which the body can rest without slipping down. So, for example, this block is at resting at this surface. Now you are increasing the angle. You are increasing the angle. So you have to finding out what is that angle at which the block will not slip down. And that is maximum angle is called as a angle of repose. So for example, if I will draw the free body diagram of this block, what are the forces acting? So this is basically a theta angle, and there will be a weight, and there will be a normal reaction. So if I will resolve the forces, this W, which is making a theta with this horizontal or this plane, what is this? Just 1 second. I think it will be better if I will draw this angle here. Yeah. So if this is theta, this is nothing but 90 minus theta. So if I will resolve this force in this horizontal, this parallel to the plane and this vertical to the plane. So what is this value? This value is W cos theta and W sin theta. What is this angle? What is this value? W sin theta. What is this value? W cos theta. Very simple, because this plane having angle of theta. So I have mentioned here theta. If this is theta, so this is 90 degrees, this is 90 minus theta. So whenever there is a angle, then you have to take the cos component. So f of cos of 90 minus theta is sin theta, and this is W cos theta. And remaining is very simple. Just take the summation of force in x direction 0. That means what are the forces acting? W sin theta. This block has a tendency to move in downward. So where the friction force will act? If we take some other color, friction force is this one. So the friction force I am denoting with F R, which is nothing but mu into normal reaction only. So the W sin theta is equal to mu into normal, which is nothing but this is the one force and this is the another force, friction force. So mu into N. If you take the summation of force in this direction, one is the W cos theta, another is N. That means N value you are getting as a W cos theta. So can I write W sin theta is equal to mu times of W cos theta. This W will cancel out. Tan theta is equal to mu only. And what is the value of mu? You already know that is tan phi. That means theta is equal to phi. So this is the maximum angle at which this block will not slip down. Okay, so the angle of repose is nothing but, you can calculate the phi value also. Just equate this, then you will get the angle of repose. Most of the time they are not framing the question, but there is a terminology, that's why I have discussed. But one question was asked in the GATE 2011, and this is one of the best question in this friction based on the concept. Most of the students have done the mistake, but I just want to know from your side, what is the question? Very simple question. Okay. 1 kg block is resting on this surface with coefficient of friction is 0.1. Force of 0.8 Newton which you are applying to this particular block, the friction force you have to calculate. What is the friction force? Mu into normal reaction. Yes or no? So this is the block. First of all, you draw the free body diagram. What is the force will act on this body? So let us suppose the force which is acting in the body is. So how many force will act on this body, Raj?
Sir, one is the applied force of 0.8 newtons. Another one is the opposing frictional force. And another one is weight, sir.
Okay. Okay, very
1
good.
into
One is the
9.8.
W. This is 0.8. So the friction force which will act, let us suppose this is Fr. Any other force?
Reaction, sir.
Sorry. One is the reaction, that is normal reaction. Okay. So that means if you take the summation of force in y direction 0, what are the forces acting? W is equal to N. So what is the N value? W is nothing but M into G, because the weight is nothing but, if 1 kg mass is given, so the N value you are getting as a G, so which is nothing but 9.81 Newton. No, the maximum value of friction force you already know, this one, which is equal to mu into normal reaction. Mu value is 0.1, 9.81. What is this value? 0.981 Newton or 0.98 Newton. So can you tell me, is the friction force is correct or is there any mistake? Can you comment on this? Just see the calculation or see the concepts. The friction force you have to calculate. I am getting 0.98. So is it correct or wrong?
I think it's correct, sir.
Okay. So that's why I told you why this question is a very best question. Now, if you see, you are applying a force of 0.8 Newton. Where this block will move? This block will move in this direction. Okay. This block will move in this direction. So the friction force will retard the motion of block. So that means the friction force is acting in this direction. Yes or no? That is clear. But can you tell, you are applying some force in 0.98, 0.8 Newton, and the block is moving in this direction. Is it possible in the real situation? Because the maximum frictional force you can apply 0.98. But how much friction force will act? Which is equal to applied load only. You are applying 0.8 Newton. The friction force is maximum is this one. So the answer for this question is 0.8 Newton is the friction force. Why this is happening? Because as the applied force is less than 0.981 Newton. So the friction force value will be 0.8 Newton. For example, if I will give you the, let us suppose this block is, the force is acting as a 0.981 Newton. Then you can say that the maximum value of friction is this one. For example, if I am applying the 1 Newton of force, then in that case, the block will be in the moving condition. Then the kinetic friction will come. Okay, they have given the coefficient of friction. Then in that case, you will apply the 0.98. So as the force is less than the frictional value, then the frictional force will 0.8 only. And you can, by using the common sense also, just take one block, you are applying the force in the forward. Is it possible it will move in the backward direction? Because the frictional force is a self-adjusting force. Whatever the force is it is acting, same frictional force will act like that until and unless it will not more than the maximum value of frictional force. For example, if I'm giving a 0.4 Newton force, in that case, can you please tell me what will be the friction force? Let us suppose force is 0.5. What will be the frictional force? This is the 12th standard concept. Suppose if you are applying the 0.5 Newton force, 0.5 Newton force is acting. What will be the value of friction force? Can you tell me, Raj?
Sir, it will be 0.5 into 9.81.
Point. No, no, I'm not giving 0.1 is the coefficient of friction. 0.5 Newton force is acting. Okay. You calculated the friction force is 0.981. I'm asking what will be the friction force if the force is 0.5? If force is acting 0.8, what is the friction force? 0.8 only, no? For
Understood,
example,
sir.
this is the block. It is resting. You are not applying any force. What is the friction force? Suppose the block is at the rest condition. What will be the friction force?
Zero, sir, because it is in
Zero
resting
only.
condition.
Yeah, you are not applying any force. If you are, let us suppose you are applied the force is 0. What will be the friction force? You calculated maximum is 0.981. Okay, you calculated this. Now you are applying the force 0.1. What will be the friction force in this case? Tell me fast.
Hmm. What, sir? I didn't understood the question.
Force you are applying 0.8. What will be the friction force will act on this block? 0.1 you are applying. In
Sir,
0.1 will act, no?
yes, sir.
Until unless it will not reach the maximum. If you are increasing 0.2, 0.2. If you are increasing 0.3, 0.3. That means when this applied force is equal to the maximum friction force, then the total will act because it's having a self-adjusting. If you are applying 0.1 Newton force, friction force is 0.1, 0.2, 0.2, 0.3, 0.3. But if you see here, it is applied 0.8. 0.8 frictional force maximum is 0.98. You cannot apply the maximum friction. Because if you apply the maximum friction force, it will move in backward direction. How it can be possible? So the only condition is whenever you are force you are applying, that will be equal to the friction force. What let us suppose the maximum value is 0.98, but only the applied force is if the applied force is less than friction force, then the friction force will be equal to applied force only. Same thing I have mentioned here. As the applied force is less than the 0.981, which is maximum value, so the friction force only is 0.8 Newton. Okay, I hope you understood this. So let me discuss the concept related to the wedge friction. Now see why we are using first of all wedge. Wedge is basically it is a tapered shaped block which is having a small angle, which is having very small angle or less angle, and that is used for lifting and holding the heavy object. Lifting and holding the heavy object. Okay. For example, suppose this is the condition given. Let us suppose there is a big block there is a big block, this one. Okay, so please see carefully how you will solve this problem. Let us suppose this is the block which you want to raise in the vertical direction. In the vertical direction. Okay, so this is the surface, and the block having weight is 1000 Newton. Now, the angle made by this small wedge is, let us suppose this angle is 15 degree. Okay, so what you want to raise this particular weight in the vertically upward direction. Now, what you are doing, you are applying some forces on this wedge so that it will move in the vertical direction. That means the application of wedge is when you want to lift a heavy weight. So even a small force, if you apply on the wedge, then you can easily move to this vertically upward direction. Okay. Now, but how you will solve the problem? That is the question. So let us suppose this is the wedge having a 15-degree angle, okay, which is resting over this surface. Now, the coefficient of static friction I am giving you 0.2, and this is the block, and this is the wedge having a coefficient of friction is given as mu as 0.2. Okay. Now you have to calculate what is the magnitude of force you will apply here so that this block will raise in the upward direction. So if you want to lift this particular block, how much force you have to apply, that you have to calculate. Okay. Then how you will do? You will first of all draw the free body diagram. Then you will write down the equilibrium equation. Okay. Now you will appreciate what is the application of Lami's theorem also. So now I'm taking the same figure in the next slide. Just 1 second. So what you will do, first of all, you will draw the free body diagram. Now this is the block. How many forces are acting in this block? One is the 1000 Newton. Okay, which is the weight. There will be one normal reaction. Okay, there will be one normal reaction, and this so there is a friction force which is given as 0.2. Now, if you are applying this block in this direction, okay, this block will move in this direction. Can you see? The next condition will be like this. The block will be at this point. This wedge will be at this point. Then the block will be like this. That means from this point to this point, it is raising. So if with respect to this wedge, the block is moving in the upward direction. The block is moving in this direction. So the frictional force will act in this direction. Let us suppose the frictional force is F2. And here will be, let us suppose there is a normal reaction. Because it is a making a contact, there will be normal reaction and there is a frictional force. The frictional force I am denoting with F2 and the normal reaction is N2. Okay. Now, the friction force and the normal reaction, you know that there will be a resultant. Yes or no? I have discussed already in case of uh, angle of friction. Let us suppose this is the resultant. What this resultant made with the normal reaction? Angle phi. How you will calculate the phi? Because you know that tan phi is equal to mu s. Yes or no? Just now I have discussed. You can see here the tan phi is equal to mu s, the resultant which is made with the normal reaction. So this is value given. You can calculate this angle. What is this angle? This angle, once you will solve, then phi value you will get as tan inverse of mu s is 0.2. That means 11.31. The phi value which you got as a 11.31. Okay. Again, I'm repeating you. This is P force which you have applied. The block, this wedge is moving in this direction. The block will move in the upward direction. But with respect to this surface, the block is nothing but it is moving in this direction. So there is a frictional force in this direction. The frictional force is this. Another force, there is a normal reaction which I have represented here. There is no issue. Now, if this is theta, this angle is theta. Can I say this angle is also theta? Simple geometry, because this angle is given as theta. What is the normal angle which will make with this one? Very simple. This is the normal reaction. So you want to calculate this angle. Okay. This is theta. This is 90. This is 90 minus theta. If this is 90 minus theta, can I say this is theta? Same thing I have represented here. Okay. So always remember whatever the angle inclined plane which is making with horizontal. So the normal reaction make with the vertical. Okay. Or if you want, you can calculate. This is theta. This is 90. 90 minus theta. Total is 90 because normal reaction is perpendicular. So the total angle is 90. This is 90 minus theta. So this should be theta. So theta value you already know. What is this theta? Theta is 15 degree and phi value you have calculated. Okay. Now, how you will solve? There is a reaction. Okay. This is reaction is nothing but the resultant of these two. So can I use Lami's theorem? Three forces are acting. One is 1000. Another is the normal reaction. And another will be the R. This is the nothing but the resultant. So instead of using this N2 as well as this friction force, I am directly using the reaction value. If you want, you can just resolve in x and y direction. Take the equation summation of force in x direction 0, summation of force in y direction 0. Again, you will get the same answer. But the application of Lami's is if three forces are acting at the same point, okay, because this force vector you can displace in any point, but that line of action should be meeting at this one. For example, this force is meeting here, this force is meeting here. If you extend, it will meet here. Now, if three forces are meeting, directly you can calculate R. What is this angle? This angle is 26.31 because this is 15, this is 11.31. This is 15, 11.31. Total angle is this one. There is a normal reaction, there is a weight, and there is a R. So two unknown, one is known, angle you know, you can calculate R as well as N. Okay, so let me calculate first R value. What is this R value? So can I write N divided by sine of 180 minus 26.31? Because Lami's theorem is the force, the angle made by the opposite. Because this is total 180, this total is 180. You just subtract this one, 26.31. Similarly, is equal to, can I write 1000 divided by, what is the angle? 1000 divided by this angle. This angle is 90 plus 26.31. That means sine 90 plus 26.31 again is equal to, what is the next one? R. What is the angle between these two? This is vertical, this is a horizontal, 90 degree. So R sine of 90 degree. R sine of 90 degree. So can I calculate this R value and the N value? Yes. Once you will solve, so what normal reaction I have considered? So let us suppose this normal reaction is N only. Okay, not an issue. N is equal to, if you solve, this value you will get approximately 494.45 Newton. Because just equate these two. Just equate these two. This is known. Sine 180, this you can calculate. This you can calculate. And value you will get as 494. Similarly, R value is 1000 divided by this because sine 90 is 1. So once you will solve, R you are getting as a 1115.56 Newton. Okay. So the R value you got as well as normal reaction. Now, if this is the reaction, can I apply the same reaction over here? Because this is the reaction offered by wedge on this particular block. Same normal reaction will act here. Now I will draw the free body diagram of this block. What is the free body diagram of this block? Let us suppose this is the block. Okay. This is the reaction R. What this reaction is making with vertical? This angle is 26.31. Now, what is the another force? P is the force. One force which is you have applied. And one will be the normal reaction. Normal reaction from the ground. Normal reaction from the ground. Let us suppose this is N dash. Now again three forces are meeting. So this is P, this is R, 26.31, and this one is N dash. Again you have to apply the Lami's theorem. Can I write R divided by sine 90 is equal to N dash, N dash. Otherwise, you can use the Lami's theorem also. Just resolve the forces in x, y, because you only have to calculate p value, no? Just take the summation of force in x direction. Summation of force in x direction 0. This value is r sine of 26.31. So r sine of 26.31, this is positive, minus of p is equal to 0. So p value you are getting as r sine of 26.31, which is nothing but R value is 1115.56 sine of this value. Okay, then you will get the value around 494.45. So this value you have to calculate the P value, whatever the minimum force you have to apply so that this block will move. You got as 494.45. So in case of wedge friction also, if you see, you can resolve in x and y direction. I have resolved like this. Or you can consider Lami's theorem also. Three forces are acting. R divided by sine of 90 is equal to P divided by whatever this angle. Then n dash divided by this angle. This is 26.31. This is 90. Then you can calculate the unknown. That means the application of Lami's theorem will be in the wedge friction also. Either you can solve the forces in the x direction, that is the generalized, or the Lami's. But the most important condition is how you will apply these forces. So this block is moving in this direction. This block have a tendency to move in this direction. There is a relative motion. Friction force is here. This is normal reaction. This is the resultant. So these three forces are acting on this block. So I have considered as a Lami's theorem. So I got as a normal reaction in R. They can ask you what is the normal reaction. Instead of P, they can ask you what is the N value. What is the resultant value of this contact surface? Then you got as a P value as 494.45. Is it clear, Raj?
Sir, yes, sir, it's clear.
If you have any doubt, you can ask me. Otherwise, I will end this session.
Sir, here we have two angles, phi and theta, sir. Which one
Yes.
is, I want to know what is the difference between them, sir.
See, this theta is basically the inclination angle. Okay. Theta is nothing but 15 degree. So this is 15 degree. This is normal reaction. I want to calculate this angle. This is 90. This is 90 minus theta. So this will be theta. What is this phi? Phi is nothing but angle of friction. Angle of friction is, if you see here, what is the angle of friction definition? The resultant which is made with the vertical. Resultant of what? Frictional force and normal reaction. So phi value you can calculate by using the mu-s condition. That's why I told you this terminology you have to understood. The friction angle is tan inverse mu-s. Whenever the coefficient of friction is given, you can calculate the friction angle. Just take the tan inverse. So same thing I have done here. Where is it? Yeah. So mu-s value is 0.2. You got as a phi is 11.31. This is the resultant, no, with the normal. So you know this particular angle, you know this particular angle. So I have superimposed with the vertical. This is vertical 26.31 because this is 11.31. This is 15, 26.31. Three forces are there. Remaining thing you already clear.
Okay, sir.